I welcome you all to yet another video on the AWS series of the high performance parallel computing. This time we will see how to develop an infrastructure for parallel machine learning applications using the Apache Spark. The flow of this video would be something like this. So initially, we look at the problem statement. So the problem statement is to train an ML model, that is a machine learning model, in AWS cloud across multiple EC2 instances, and then use this model to predict the results of based on a given data set. Okay. We will specifically try to learn how to quickly build and use a 4-node Apache Spark cluster, which will eventually be used for training this ML model in the AWS environment, given a data set. Okay, so a third point, we will try to see how we harness the Spark's MlLib capabilities to achieve parallelism via the application hooks in a parallel processing environment. Okay, and finally we will try to see how the results of a Spark ML job look like how is the file that gets rather the trained model file that gets generated, what is the console output, how the jobs get distributed across the nodes in the multi-node Apache Spark cluster. We can see all these things through the console logs, and also we'll look at the predictions that come as a result of the ML job execution. Okay, so let's start with the session. I would like to first brief a little bit about what is Apache Spark at a very high level. Apache Spark is Apache Spark is a platform which enables user to distribute their processing jobs across across multiple nodes or multiple compute instances without even worrying about the synchronization, the scheduling, and integration of results and distributing the tasks across, breaking down a task and then distributing it. All these things will be taken care by the underlying Apache Spark cluster. So all that the developer or the user is required to do is just write the application logic for the machine learning in our example or in our case, and then the underlying platform will take care of running breaking down this complete processing of the machine learning into multiple jobs and chunks, and then distributing it across the nodes for parallel processing. So this will definitely help us get faster results compared to running these jobs on a single system, even with having good amount of processing power or capacity. So the result with today's example, we'll basically the example that we are going to take today is it's basically we are trying to predict the quality of the wine. I mean the beverage wine, based on the different parameters that we have in the samples seen in the wine data set. Okay, so there are different parameters like the acidity, pH level, and there are the content of sulfur in it, and there are many such parameters. And ultimately, all these parameters constitute to contribute towards its quality. So we are going to analyze all these parameters in the data set, and then this task will be basically done by the machine learning job on the Apache Spark cluster. So this is the problem statement that we are going to use for today's demo. Let's look at what tools we'll be using. So we'll be basically using something called as EMR service on the Amazon on the Amazon cloud, which basically enables us to create the Apache Spark cluster very quickly. And we don't need to even worry about how to stitch together the Hadoop and Apache Spark and other modules like Yarn and Hive together. So all these things will be provisioned by EMR. So it makes the life of the machine learning developer very easy. I mean, the developer can only focus on the machine learning or the application logic, and the EMR on the AWS will handle the underlying infrastructure. Although there are some challenges where, with respect to module integrations and different Python modules, if you want to integrate in EMR, there are some challenges that do come, and then we'll look at some of them. Like for example, we have a third-party Python modules like NumPy and PySpark or other pandas, which basically are not bundled along with the EMR's Apache Spark offering. So we look at how we can handle those things separately. Right. So right now this video focuses on how to build the Apache Spark cluster using the EMR. So on the screen you see this is the AWS console, and then I'll be selecting the EMR option here. Go here. It's pretty simple. I mean, creating a cluster. I'll just go here, click create cluster. Wait for the application bundles to load. Yeah, let me name the cluster. Let's say Spark cluster 1, and let's choose the EMR version that they are exposing. Let's choose EMR. The latest one's EMR 7.1.0. And EMR gives us an option to select what type of application bundle we would like to include. So for us, we will be looking at the Spark, okay, the Apache Spark. Now, the moment you select Apache Spark, there are some standard widgets or packages or applications that get bundled along with it. So out of which Spark 3.5.0 and Hadoop 3.3.6 are the compulsory ones, because Hadoop acts as the HDFS data file system for as a data store for the Spark jobs. And yeah, these two modules are compulsory. So we'll try to keep this as default and go ahead with the next configuration item that we have. So it also gives an option for us to choose which Linux base OS we would like to choose. I would like to go ahead with the Amazon Linux, please. It's easily available and don't need to spend extra for that. Okay. Now let's look at the cluster configurations. So since our cluster will be manually, we know that we are going ahead with a 4-node cluster. So we'll mostly align with the manual mode of cluster configuration. So we have to choose uniform instance groups, okay? And then when it comes to choosing the compute capacity, we will go ahead with the M4 large, okay? So the basic requirement for a decent Apache Spark cluster cluster is somewhere have at least 2 vCores, 2 cores of CPU, and around 8 gigs of primary memory. So M4 large gives us this option, as you can see it here. I'll choose M4 large for this. Similarly, let's look at the other the core and the worker nodes as well. Let me choose M4 large here again. And then now, as you can see, the task 1 of 1, right? So this task is nothing but the worker nodes where the master will distribute the jobs to. Okay, let's choose the same compute instance for this as well. Task 1, and then let's choose hold on, let's looks like it has got hung. Okay, now it is come. choose m4.large. Okay, then we'll be keeping all the storage capacities as default, but as we don't need much storage, so 15 gigs is sufficient for this. So now next configuration item is cluster scaling and provisioning, and basically, as I've told before, that we'll be looking at a manually sized cluster. So we'll have one core and we'll have 3 tasks, or we can say probably you can restrict it up to 2, so that we can try to make it like a smaller cluster. Try to save some money because this is not free. And I mean, there is a billing component that gets added to this. The number of instances you add to the cluster. So let me choose 2 worker nodes and 1 core, right? Next comes the networking. So these we have already created a VPC before. So I would not like to go ahead I'd not like to explain what VPC is, though these are some basic networking components of the AWS EC2 environment. So which are, it's pretty simple, like defining some network partitioning. So we have a subnet, we have a VPC configured, and then moving to the next configuration in the EMR is steps. So now steps is something like this is your actual application. Okay, so your ML application, like your Python code or your Scala code or a Java code. Okay, so this is where you can, if you want to run the your code along with in this EMR workflow, we can do it. Otherwise, later on, else we can also do it as a Spark submit job later on once this cluster is up. So right now we will not run anything here, but there are some custom scripts that we might have to run in order for us to resolve the dependency issues in case if we get. But right now, let's keep it as empty and just create a cluster out of it. Yeah, so we'll keep the steps as empty right now. Cluster termination and node replacement, we don't need to do anything here. Bootstrap actions is again something like if you want any extra additional packages that you want to bundle them along with the along with the Apache Spark VMs while they are getting built. So this is where we provide the bootstrap actions. This is basically the bootstrap action is nothing but choosing either a shell script from the Amazon S3 bucket. So we'll not do this right now. And then we have to, the important thing is we have to provide a location for the cluster logs. Okay, so we have created a cluster, the S3 bucket. Let me give the location of S3 bucket. S3, let me go to the S3 bucket and then just mention the bucket ID URI. So this is the bucket we have. And this is the location, right? Try to get the, hold on. So go back, S3, have the bucket name here, and then the folder. Right. So this is the folder where all the cluster logs will get stored. They get generated and then they get pushed to this location. Okay. Before that, let me try to empty this logs directory so that we know all the previous logs we can not get confused with those logs. We delete them. So here we have all the previous cluster logs deleted, and then let's go back. It's a clean S3 bucket directory. We don't want to encrypt the logs. Keep it as it is. Tags, we don't want to give any tags because we're not going to monitor or do any watch jobs on it, which tags may ultimately be used for sometimes. And software settings, we don't want to override any settings. We are going to keep it as everything as default. Coming to EC2 key pair choosing the EC2 key pair. So for the security configuration is we would like to keep it as default. Anyways, this is optional configuration, but we have to choose the SSH keys. So I have created the SSH keys. Again, how to create SSH keys, and these are all part of the basic EC2 instance creation and management workflows. So we'll not go through that. So we will be choosing Spark cluster keys as the EC2 key pair for. So these keys will be basically used for later on connecting to those Apache cluster VMs, while remotely or through PuTTY or any of those SSH clients. All right. So while next section is the identity and IAM access management, which is IAM, and then we're basically going to choose the default role here. Okay. This configuration it basically allows Amazon EMR to provision resources and perform service level actions based on what type of different roles you have configured and how we want to have access to, how we have access, provided access rules for those IAM rules in the resources. So this is all for that. Right now we'll be selecting default role. Similarly for the instance profile, we'll be again choosing the default role here. That's it. So next, the custom auto scaling role. This is optional because right now we're putting this, bringing this cluster up in a manual static 3-node or 4-node cluster. So not much concerned about it. With this, let's try to create the cluster. So now, as you can see, the status as it is starting. In a couple of minutes, it's basically we'll see all those three or four VMs getting created. I believe 4 VMs will get created, and these 4 VMs will be those VMs where the Apache cluster, Apache Spark cluster will be running on. So as you can see, those VMs have started getting created now. Let me quickly check the EC2 status window for instances. So go to EC2. Let's go to instances. We see 8 instances, out of which 4 will be initial ones, and these are the old ones. And these 1, 2, 3, 4. These 4 VMs are the ones which are created by the EMR workflow. Okay. Now on these 4 VMs, there will be master, core, the primary, core, and the worker VMs. Okay, or the slave VMs, as you can say. As you can see here, this is master, and the rest of the 3 are the slaves. Okay. So we will basically be running our jobs on the master VM. Okay, and the master then distributes the processing across the other slave nodes. So now, as you can see, these instances have gone in running state. Let's go back and check our cluster state now. Still showing starting. Eventually, once all the platform is ready, the status should go from starting to waiting state. So if you see the status other than waiting, then there is some problem with the in bringing up those VMs and the Apache cluster. We need to debug those issues. So the green state for the successful Apache Spark cluster is you should see the status as in the waiting mode. This should be seen as waiting. Okay, it takes a while. I mean, around 5 to 7 minutes for the cluster to come up completely. So we will try to check this after 5 to 7 minutes once the cluster goes in the waiting mode. All right, we waited for almost 9 minutes, and here we see the status of the cluster to be in the waiting mode. I just clicked here, and then you can see the status, what the waiting status means. It means that cluster is ready to run the steps. Now, now before we actually jump into running the scripts, we need to first try to log into the master node, okay, primary node. So let me go to the EC2 instances and go to the master node here. So this is the master. Let me connect to it. Make sure you connect to the master as the Hadoop user. Okay, and you can try with either of the EC2 instance connect or the SSH client. Either way is fine. Now let's see if we are able to log into the Apache clusters master node. Okay, there we go. Sometimes, users are not able to log in here because and users get the message that check the network connections to log into the console. So but at that time we need to make sure that the networking configurations, as you see on the screen, the where is the security part of it? Yeah, the security groups, right? The inbound rule should contain. We should enable the port 22 TCP. I mean the SSH port should be open to the VM. For this configuration is there in the security groups for that particular VM. So we need to enable this port, and that's it. And we should be able to log into the Apache Spark master node, or any of the nodes for that matter, because all of the nodes use the same security group, right? So let's see if there are Python installed on it. Let's see if pip3 phrase reports any results. So there you see we have all those Python libraries available. Let's see if there is PySpark available. So we see that PySpark is not available because we will basically be using PySpark's library, which is it's MlLib offered in the Python for the Python programming language. Let me try to install the PySpark libraries on all the nodes. We need to make sure the PySpark is all the nodes are in sync for these Python nodes. Okay, so let me get them installed one by one on all the nodes. Okay. All right. So now all the required libraries of Python have been installed across all the nodes. Just to show it to you what I have, what commands I've run. So it's basically sudo yum install python-numpy. So by default, the numpy module or the package doesn't get bundled. So this is the command that I have to run across all the Spark nodes. So starting from the master, we have to go one by one towards each and every instance here. So each and every node here. So as you can see, I've run this installation command on each and every node. Okay, one by one, go, and here go, numpy, and this is the master node. Okay, now we have everything that we need from the programming libraries and binaries perspective. Now let's try to submit the Spark job. Now winml training.py, this Python file, let me quickly show you this Python file. So this is basically MlLib code, which basically reads the training data set from the S3 bucket that we have put, and then it goes through a standard machine learning algorithm using linear regression to build a model, and then do generate the F1 scores based on the prediction that we generate using the I'm using the random forest here, but we will try to see we'll try to use different models. But right now, let's try with the random forest and try to derive the F1 scores for the accuracy over the quality parameter of the data set. Okay, so this is the machine learning code in Python that we will be running in parallel across all the nodes. So the command for running this in parallel is spark -submit and then the Python file name. Okay, just run this and let's wait for the console logs, and I will try to explain the console logs here. So now you see here Spark version 3.5.1 on Amazon One. It started executing the job, and you'll see this 172.31.61.220 is the master node, which is the resource manager here. Okay, now this is going to distribute the jobs across other nodes. Okay, now it has already started. Okay, let's see what other nodes it sees as the nodes for distributing the jobs here. Okay, so right now it's running on the master node here. Okay, so now see it has read the data file here. You can see I've just put some logs here, a data set headers here, the fixed acidity, volatile acidity, citric acid, and these are all the data set columns we have, and there's a quality parameter here at the end. Okay, so now this part of the processing is being done by the master, and now as you can see the processing has started getting distributed across other nodes also. Since the logs are running a bit fast, I'll go back to those logs once the processing stops. Okay, now as you can see here, this is 172.31.57.115. This is another node, which is a slave node. This is the slave node that I'm talking about. So 220 is the master, and 115 is the IP address ending with 115 is the slave node, and IP address ending with the last octet of the IP with .220 is the master node. Okay, now let's look at the results if it has generated any. Okay, so you see here the random forest task was done by the master node. Okay, see these are the random forest dot results for random forest step, and this was done by the master node. Then rest of the next, the task 0.0. So this is how the task gets divided across the nodes here. You see here task 0.0, 1.0 and till 11. So this machine learning task has got divided into 11 parts. Okay, and got distributed across these nodes and 62.159, 57.148, 57.115, again 62.159. So the resource manager starts distributing with different, it partitions the job and then sends it for processing across the slave nodes in the cluster. Okay, and this is how it basically then finally again integrates the results, and then you see here the result is being integrated. Most probably we can see it. Yeah, here you see the random forest job has got completed here. Okay, you can see here. So this is how it divides. Okay, let's go to the next step. You see here the partition vector is this, and then let's go down what it shows. Now the execution of the machine learning algorithm or the machine learning program has completed successfully. Okay, I'm just going through all the logs that we see and trying to gauge how the jobs are getting partitioned and divided into multiple tasks across the Spark nodes. Okay, so you see it tries to do some scheduling. It tries to find some missing tasks and then finds it and again puts it back processing. Yeah, there you go. And we see some logs out there for I'm trying to find where are the logs for the predictions. Okay, here you see there. See the predictions here. Now this is the actually result. This is the actual result of the prediction based on the quality label. And what is so for all the samples where the quality parameter is set to 5, the predictions are seen to be the finest quality of wine is basically mapping to the quality parameter where it is seen as 5. Okay. Now let's look at the F1 values also, which is the ultimate goal of this F1 score, which is ultimate goal of this machine learning algorithm. Here you see the F1 scores here as well. Okay, this is the result, and we have got the F1 score of around 0.68, which is like close to 0.7, which is pretty good. Although we should try for like a little bit more, like maybe 80% or 85%, but still, we will try to optimize this with improving the type of training we have used. Right now we have used linear regression. We'll try to use some other models as well. So as you can see, the accuracy we have achieved till is around 0.68. Okay, so which is okay. I mean, we can. It's too early to judge whether it is right or wrong, but yeah, right now the machine learning algorithm that we have implemented is giving us the accuracy of 0.68. Okay, and this is how the complete process of training a machine learning model has completed. Now, as a result, you can also see the RMSE error here, the root mean square error, which is 0.31. And the last thing that I would like to let you guys know is that this program also generates a model file which we would be using. So we should see some logs around it here. Let me see if we can see. Okay, yeah, here you see. So multi-part upload output stream is closed. Now this is S3. In the S3 bucket, there should be a folder directory called as train files, which are generated by the algorithm. Now let's quickly go to the S3 bucket and check the directory for if it has written the model properly or not. Now let me go to of all the of the model file which it has generated across multiple tasks. It is that it has executed through. Okay, so the expected result here is we should see multiple part files of the model file getting created in the S3 bucket. So let's go to the S3 bucket. This is our S3 bucket, and let's go to the directory training model.model, and this is where the model file should be written. Okay, let me show you that log. Okay, here it should be here. Okay, training model.model. This is a directory in the S3 bucket where you should find data, and these are all the part files of the model that it has generated across the nodes. Okay, next step is basically we will try to use a little variation in this and try to use the pipeline and see if we can assemble all of these together into one model file and then use it in probably in a Docker or something like that to use it for some transfer learning applications or stuff like that. Okay, so this in short is the video on how to starting from how to let me start again, like starting from how to starting from what is Apache Spark and how to build the Apache Spark cluster using EMR. What are the options that EMR gives us to customize the Apache Spark cluster? How to integrate S3 bucket into the EMR, and ultimately in the Apache Spark. Next is we learned how to use the Spark's MlLib capabilities to create a Spark context and a Spark session to basically distribute the machine learning jobs across the master and the slave nodes. The master node control it acts like a resource manager and controls the scheduling and distribution of the jobs across the cluster. Okay, and lastly, we also saw, like, in case if there are any missing dependencies or Python libraries missing, how do we install them and have them available across all the nodes. And then finally, we generated the training model and then dumped it into S3 bucket. So this is in short like how to quickly build a machine learning application and get the results, get the predictions, build a model using the Apache Spark cluster. Okay. So I'll be shortly posting the code on my GitHub repository. The details will be in the description. If you have any queries or if you want to know more on this, and if you want to dig in more, do not hesitate to reach out to me. My email address is there in the description, and please like and subscribe my video so that people I have that motivation to create some more hands-on videos on various services available on the AWS cloud platform. All right, with this, I would like to thank you, and we'll see in the next video shortly.